Let's talk about the next unit, which is the probability of let's talk about using something called Venn diagrams to find the probability of an event. Now, this is interesting. This lesson is about in the last lesson we found, if we imagine like there's a bag of marbles, or maybe like a classroom of students, and we said, what is the probability that the marble was green? What was the probability that the student was a girl? What was the probability that the marble wasn't black? Or what was the probability that the student wasn't American? In today's lesson, we want to ask the question, what is the probability that a student in the class takes French and biology? What is the probability that the die is prime, the result on the die is prime and greater than 2. So there's 2 or more conditions that must be met on an individual event. That's today's lesson. In the next lesson, we're going to say, what is the probability that this happens and then this happens? So the next lesson is about the probability of successive events. Today, we're just talking about the probability that 2 or more conditions are met on one event. So let's set up a scenario. And the scenario is there's 60 students in a class, okay? And we know that 28 take French, okay? We know that 25 take biology, okay? And 5 take both. And so the question is, you might be asked the question, how do we represent the first one? So the question would be, what is the probability? I could ask a bunch of things. So what is the probability that the student takes French? So for example, I might say, what is the probability to take French? What is the probability to take biology? What is the probability to take French or bio? What is the probability that they take French and bio? What else could I ask? I could ask you, what is the probability that they don't take French or biology? Are there students who don't take? So these are the things we're interested in. I might say, what is the probability they take French and not bio? So these are the things we're interested in. Once again, I'm just picking one person, and I need to find the intersections, or the intersection, or the union. So let's first of all, let's get a visual. So the first thing we're going to make a visual. We're going to use something called a Venn diagram. And a Venn diagram is a visual used to represent sets. Okay, so we have a couple of sets. First of all, the first set is the whole class. We'll call that U for the universe. And we're going to represent that with a big rectangle. Okay? So this is everyone. All 60 people are in this rectangle. There is no one else. The question of, there's some kids in there. We know that there's some kids who take French and some kids who take biology. Well, we're going to represent those with circles. So we're going to call these, instead of A and B, I'm going to call them F and B. So F and B are the sets of students who take French and bio, and we're going to use circles. Now, you may ask, well, how do we write that? Well, there's 3 ways of putting the circles in there. There's 3 ways. I could put, 2 circles that are next to each other. I could put 2 circles, I can put one inside the other. Or, what we're interested in, I can put 2 circles that intersect each other. Okay? And that's what we're interested in, because How do you know that? How do you know that there's some overlap? Well, we're told that 5 take both. So we're going with this. Just some vocabulary. If there's no intersection between the two sets, we say they're mutually exclusive. So there's no overlap. What's going on here? Well, we would, if this was F and this would B, we would say that B is a subset of F. Which means that everything in B is in F, but not everything in F is necessarily in B. For example, multiples of 4 is a subset of the even numbers. But here, this is just a regular, so let's put this up here. Okay? Let's put this up here. So I'm going to label it with an F and a B. Sorry, a sneeze coming on. So, okay. So we have 4 regions here. We have a bunch of regions. So let's talk about this region here. So the question is, how do we fill these numbers in? With Venn diagrams in math class, we want to fill these in with numbers. So anyone have any suggestions? What goes where? Well, let's start with this 5 take both. So you might think, oh, well, the 5 kids go here. So this region is known as the intersection of F and B. And what we use is we use F upside down U, B. Okay. Now, what's going on here? This region, well, we know in total there's 28 kids taking French. 5 of them take both. That means that 23 only take French. What we're going to see in a little bit is this region is actually French and not biology. Once again, recalling this simply means not B. What's going on over here? What's going on over here? Well, this is biology. There's 25 kids taking biology, 5 or both, that means 20 take only bio. This region here is French, not French, and bio. Okay, but ignoring all this, we have these areas. What's the last thing we're let's see. And then so we have So we have 23 plus 5 is 28, and 48. So the other thing is this whole region. This is the union. So this is F union B. This is the union. We will get back to all this. And so, and is there another region? Is there anything we have to do? And the answer is, yeah, there's this whole area outside. We knew there were 60 students in the class. We knew in the unit there's 48. Therefore, there's 12 kids who don't take, there's 12 kids who don't take either French or biology. So we're ready to answer some probability questions. So what's the first probability question? I might say, what is the probability a student takes French? Well, I wrote it over here. Let me do it in another color pen. Okay. What is the probability a student takes French? You say, okay, 28 over 60. And you can reduce that and turn it into a fraction. That's fine. What is the probability a student takes biology? Well, we have the 5 and the 20. 25 over 60. Nice. What is the probability they take French or biology? Well, let's see, 23 plus 5, 48. 48 over 60. Okay. What is the probability that a student takes French and biology? French and biology. Well, that's in the intersection. That's 5 over 60. Okay. So the question, you're looking at these numbers and you're like, they seem to be connected. Is there a connection here? You're saying, oh, wait a minute, like if you add these together, you get these together. Now the question is, so the next question, is there a connection between the union and the intersection? Right? So I might say to students, originally, I might propose, I say, I may propose to students, what is the probability of the French or biology? And students might say, oh, it's the probability of French plus the probability of biology. And we have a little problem there because 28 plus 25 is 53. But in the union, we saw it was 48. So the answer is no. This is false. It's going to be true somewhere, but it's false. So what do you think? Well, it turns out that the probability of the union of two events is equal to the probability of the first plus the probability of the second minus minus the intersection. And the way I want you to think about it is I want you to imagine two circles. Here's French, here's biology, right? And I bring them together, there's 5 overlap. If I count both circles, I'm doubling the overlap. So I have to take one of the overlaps away, subtract off the 5. And you see here, once again, the probability of the union is equal to the probability of the first plus the probability of the second minus the intersection. Nice. So let's do another example. Let's see. 450 students are in a school. And 200 take soccer. We have 300 take econ. And 75 take neither. So what is the probability? So the question is, I ask you, find the probability of someone taking soccer and econ. What is the probability to take soccer and econ? I want you to think about that for a second. Okay, well, in this case, and when you ever have these problems, once again, I'm picking one student, and I'm looking to see if multiple conditions occur. This is not successive events, which we'll see in tomorrow's unit. We're just saying, here's one kid. Are certain conditions met? Well, we can go back here to the union. So let's see. So we know the union. We can use the different letters, but we're fine with it. So how many kids are in the union? How many kids are in the union? Let's see. So first of all, how many kids are in the union of, can you see that? Yeah, of econ and soccer. In the union of econ and soccer. Okay, well, my tarot, sorry, I'm being lazy. Well, let's think about this for a second. Well, we know there's 400 students in the class, but 75 take neither. So that means that 450 minus 75, which equals 375, is equal to the union. Okay, so that means that the probability of the union is equal to the probability of soccer plus the probability of econ minus the probability of the intersection. Now, you don't have to write this whole thing down. You can write X for that. That's fine. So let's see what we have here. So we have 375 minus 500. So the probability of econ and science is equal to 125 over 450. Once again, 375 minus 500, and this becomes negated. It's 125 over 450. You're always using the formula for these types of questions. So, I asked so once you have the intersection, you You can make the chart and answer a bunch of questions. Once you have the chart, so you can say, you know what, I'm going to make a Venn diagram. And, so you have the universe here, and you have your econ and your soccer, and you say, you know what, there's 75 kids who don't take either. Let's move that back up. And you say, there's 200, we figured out that 125 are in the intersection, because the number on top is the actual number of people, number of kids. You might say, Mr. Adler, you might say, do I have to take the probabilities? Can I just do the numbers? The answer is, yeah, it works also, because remember, everything you can get rid of the 450 in the denominator, so you can just work with the numbers. The union is equal to the total f of union B is equal to f plus b minus the intersection. So, and that's kind of what I did. The probability is 75 over 450, but there's still 75 kids here. The probability of the intersection is 125 over 450. So there's 125 kids here in the intersection. There's 200 kids who play soccer. That means 75 are here. What's going on here? How many people took econ? 300. There is 175. Now, the question is, so now let's talk about some notation. This is kind of fun. I just want you to recognize the notation. How are we doing for time? Okay. So we know that 125 is represented by, that 125 is represented by E, this symbol. We know that, and we know that the 175 and the 125 and the 375 is represented by E union S. The question is, what are these other regions represented by? And so I'm going to go this next part. I just want to go over it just so you actually see what it looks like notationally. And so what we're going to do is we're going to look at this diagram. We're going to go over a couple of things. So let me erase this. Let's use some more Venn diagram. Now this is important if you're going to do computer science. This kind of shows up, or maybe this idea of set notation. So let's see. A second, sorry. Nice. Okay. I'm going to make a box with 2 circles in it. And then I'm going to call this A and B. Okay, I'm going to do this 12 times. Let's see. So first of all, we're talking about shading. We're going to shade A. Okay, and you get your pen. Maybe you have a blue marker and a red marker, and we're going to shade them. And let's see. So blue for A and red for B. Okay. Well, I'm asked to shade A. So you go, okay. Here's shading A. Easy. Next. Let's do another one. Ready? Here's another Venn diagram. A and B. I would like you to shade in B. Okay, well, that's easy. Here's B. We notice that there's some overlap with A, but this is B. Next. Sorry. Next. Not A. Circle, circle. A, B. Not A. Where is not A? Well, not A is everything that's not in A. That's not A. Next, let's move on. Not B. not B. You say, okay, that's fine. Where's not B? Okay. That's not B. It's everything out here and this part here. Nice, let's move on. A union B. Where is A union B? Well, it's bringing together A, everything in A, and everything in B. We're going to bring it together. So I'm going to highlight everything in A. I'm going to highlight everything in B. And union says, what is shaded? Well, all of this is shaded. This is A union B. Anything that is shaded is part of the union. Nice. Now, A intersect B. You're like, okay, no big deal, this is fine. A intersect B. So this is, everything shaded. The union, and this is the intersection. Intersection, the overlap. And so you're like, okay, well, I'm going to first shade A. Maybe you want to make it really light because it's not the whole thing. And let me shade in B, shade B. Okay. And the instructions are to find the region where it overlaps. You go, okay, this region here, this is the intersection of A and B. Cool. Let's move on. Now here's the interesting thing. Ready? Ready? I want not A and B. This means, once again, the intersection of not A with B. So draw your circles. This is kind of cool. I like this. Draw your circles. My A and my B, right? You see that? Nice. First thing, shade not A. Okay, shade not A. Next, shade B. I mean, you almost like pretend you don't know what's in here. You're just like, okay, shade not A, shade B with red. Let's shade B with red. And I'm asking for the intersection. So you go, okay, well, this region here, let me use a better pen. Ready? This region here, is represented by the intersection of not A and B. This is known as only B. This is only B. Right? So this is the part of the intersection where there's some kids who take biology, but not French. Once again, these are the kids who took bio and French. These are the kids who only took bio. So once again, you might see this notation here and go, oh yeah, that means only B. Well, what do you think how do you think only A is? Yeah, you guessed right. Only A is represented by A and not B. Or, yeah, and let's just go through that again. It's kind of interesting. Once again, you might see it on the IB exam. I just want you to know, only B. Let's see. Once again, let's shade A. And let's shade not B. Once again, pretend you don't know. You're just like, okay, Mr. Adler said shade not B. Okay. Like, la-di-da-da-da, shading not B. Okay, I've asked for the intersection. You're like, okay, well, this part here is the only region that has both blue and red. Once again, what was it? What was my example? Yeah, French and bio. So these are the kids who only took French but did not take bio. So this is the notation for only B and only A. Another thing, this is kind of advanced. This is something advanced. So let's move on. Let me keep going. You'll like this one. Ready? This is a little old school, but it's kind of important. And this might be, if you want to do if you're paper on logic, this is kind of interesting. Logic and computer programming and stuff. This might be interesting. So I would like you to make Venn diagrams for. I would like you to make Venn diagrams for the following four. I want you to make not A union not B. I'd like you to make Venn diagram for not A and not B. I would like you to make a Venn diagram for A union B not. And I want you to make a Venn diagram for A intersect B not. So once again, the union of not A, not B, the intersection of the complements. I want to know what the complement of the union is, and I want to visually see what the complement of the intersection is. Okay, let's get to work. So once again, two circles. Pretend you don't know what I'm asking for. This is A, this is B. Okay, where is not A? You shaded not A. I'm shading in not A. Okay. Now I'm taking my red marker and I'm shading in not B. Let's see. Not B, not B, not B, not B, not B, not B, not B. Okay, well that's almost like everything, right? It's kind of cool, right? So here we go. So we have it's the union. So like we have like everything. It's the union, so we have like everything. Okay, next. Not A intersected with not B. Okay, same idea. Well, we kind of know, we can kind of see what's going on here. I mean, I could do this again. Let's do it again. Take our time. A, B. Not A is out here. Oh, sorry. I made a mistake. That happens. Use pencils when you do Venn diagrams. So here's not A. And let me use my red pen for not B. And you would say, oh, you know what? Mr. Allen, the only place that the red and the blue touch, because once again, you've asked us to do intersection. The only place where the red and blue meet is outside here. So this is the intersection of not A and not B. Okay, cool. Right, right? Okay, let's move on. What's going on here? The union, so AB, the union, so let's see, we have AB, and here's A and B, and I know what A union B is. It's right here. So where's the complement of this? You say, oh, wait a minute, it's out here. Interesting, right? What's going on here? What's the complement of the intersection? Well, I know what the intersection looks like. I know where the intersection is. I know what the intersection is. We did that over there, right? Well, what's not in this area? Well, that means the complement is here. Very interesting. So if we think about this logically, the intersection of the complements is equal to the complement of the intersection. And the intersection of the complements is equal to the complement of the union. And this is actually known as DeMorgans laws. And it's just kind of fascinating from a logic point of view that not A and not B is equivalent to not A or B. And DeMorgan's law shows us that not A or not B is equivalent to not A and B. So the ramifications of this are very interesting in computer science. How do you do programming with if-then statements and ands and ors, and the negations, and also the implications of how this plays out in language. So this might be an interesting topic. So this is outside of the course. This you need to have in your mind what's going on. This will, once again, well, let me cover this. This is A, B, not A, not B. Union, intersection, only A, only B. Good.